All right, hey everyone. This is the lecture, LING120 lecture for chapter 6. So I'm going to go ahead and go through this, and at the end I'll have the usual comprehension questions for you, and I've got the assignment description, assignment 6 description in a different video, so do make sure to check out that other video for the assignment 6 description. So to get started, go ahead and I guess enjoy this meme. I thought it was funny. It's kind of related to the machine learning stuff that we did from chapter 5. So I enjoyed it. Thought you might too. I won't play this video for you guys, but it's a very funny video. I think this is the SNL video. So definitely go ahead and take a minute, go to this URL and watch this. It's like 4 or 5 minutes, and do this when you need a good laugh. It's really funny. So some warm-up questions for chapter 6. You guys have done the chapter 6 reading guide, you've read the chapters, you're prepared for this. So to kind of get started, think to yourself about what dialogue systems or chatbots mean to you, how they're useful in the real world. Do you use any on a day-to-day basis? What's your general impression of these chatbots? How well do they do? How well do they converse with you? How well do they accomplish the purpose that they're built for? Those types of things. What challenges do you see in the development of these types of systems? So clearly they're usually not simple systems. What challenges do you think might have occurred when the developers were trying to make these systems? And do you think eventually the goal should be to have these symbols or these systems resemble conversations with humans? They're already starting to approach this, but do you think that should be a goal for us? And if so, how should these dialogue systems be designed? It's kind of a very big and open-ended question, but something to think about nonetheless. So to get started with talking about having the computer chat with a human, we need to think about the principles of human conversation in the first place. So in a human conversation, the speaker will initiate the conversation after they think about what they want to say, what the purpose of the conversation is, and how they want to communicate that. And the listener has to listen to all that, notice all these different things, understand the literal context, or the literal meaning, and also the contextual meaning of what the speaker said and what they intended as well. So it's a fairly complex process, even though we do it, very intuitively or very simply every single day. Then the listener will formulate a response to all that and ensure that all the general social conventions and niceties are in place. So, making sure that you don't respond too curtly or rudely, making sure that you follow all the kind of conventions of natural human conversation, especially like if you think about leave taking, how you say goodbye to somebody, saying goodbye to somebody, at least here in English in the US, is actually a fairly complex process. So things like this, the listener really has to think about. And if you think about it, humans are very skilled at this from ever since we were children, and we're so good at it that we don't even know how we do it. So the first step in building a good chatbot, a good dialogue system, is to understand how humans talk to each other in the first place. And then we want to try to imitate that with a computer. And so first we have to analyze how humans do it before we can look at getting the computer to do it as well. So we have to really look at the linguistic subfield of pragmatics, right? So we have, at the lowest level, we have things like phonetics and phonology. Above that we have morphology, the study of individual parts of words. And then we get above that and we get to, we get to the lexical level, individual words. Then we go up another level to syntax, morphology and syntax is grammar, word order with syntax. And then we get up to semantics, the meaning, and at a very top level, a lot of this, at least when we talk about, in your intro to linguistics course, we'll say that the top level is pragmatics, which is the study of kind of how language works in context. So it's a subfield of linguistics concerned with conversations and how context contributes to meaning, how conversations are organized, all this type of stuff. So in pragmatics, we describe human dialogue in terms of moves, and not even just human dialogue, but also written pieces of work. You can take a research article or a blog post, whatever you whatever you want to look at, and you can describe the different moves happening in the document. So we have initiating moves, like making a request, asking a question, commanding somebody, making a general statement, things like that. We have moves that are more responsive, like saying yes or no, giving a longer response, having conditionals or partial agreement, things like that. And then you have also like dialogue management moves, clarifying things, just generally nodding, exclaiming things, all these different types of moves, right? And so, oops, sorry. So you don't actually have to answer this. Just kind of think to yourself, how does understanding all of these make sense for a dialogue system, especially given what I mentioned on the last slide. You have to understand how human conversation works before you can move on to making computer do the same thing. Right? That's a fairly recurring concept throughout the course, right? Is you have to understand how humans do it before we can try to make a computer do it. So how does understanding all this with pragmatics make sense for being able to make a dialogue system? So we can also talk about what individual utterances in a conversation do. They can inform people, remind you, command you to do something, refuse, accept. These are all different speech acts, right? As I have listed here, these are different speech acts. And you can talk directly, indirectly, these different types of things. So again, how does understanding these make sense for a dialogue system? Just something to think to yourself. And we also have these Gricean maxims from H.P. Grice in the 70s. We have these 4 Gricean maxims that are very big in pragmatics. The maxim of quality, making sure that you give correct information. Maxim of quantity, you don't want to talk too much. The maxim of relation, you want to say things that are relevant to the conversation. And the maxim of manner, you want to avoid ambiguity, be very clear, you want to be orderly, these types of things. So you want to incorporate all 4 of these maxims into a chatbot. If you have a chatbot that, for example, gives you information that's not relevant, that is violating the Gricean maxim of relation. Or if you have a chatbot that lies to you, it's violating the maxim of quality, right? So you have to make sure that you have these types of things in a good chatbot. And so again, videos that I won't show to you now in this video, but I definitely recommend you go and check these out. If you go to this first link, this takes you to a YouTube playlist, right? You can see that right here in the URL if you've never noticed that before. It's and list equals. So you can go here and check out a whole bunch of different chatbots for a large number of different things. I think there's literally a couple dozen videos. They're all like 2-3 minutes a piece. I think a lot of them are like chatbots you can talk with on maybe Facebook or something, and they're just you just type back and forth with the computer. So check that out if you to get some examples of good chatbots. And then also we have I have a link for you here to the Wobot. I think it's from, no, I don't recall exactly where it's from. I think it might be from Facebook, possibly. I'd have to recheck out the link, but it's a chatbot that can help you kind of act like a therapist. So kind of like you've read about Eliza, kind of like Eliza back when that was originally built, kind of acting like a therapist or a psychologist. And the Wobot can actually help people with depression. And so a very useful chatbot. And there's another link that I have here for you about how this chatbot works, right? technologyreview.com. So definitely feel free to check those ones out as well for some examples of chatbots. So how to create a dialogue system. This is a very, very, very complex task. And so I want you to pause the video and ask yourself, what are some of the tasks that come to your mind if somebody asks you to make something complex like Siri? So somebody says, I want you to make Siri. What is the first thing that you need to do? What do you need to do after that? And then just try to think of all the different steps that you'll have to go through until you can finally say, I have a functioning dialogue system. So pause the video and think through that. So I'll go ahead and walk through these now. You need to first, like always, you need to study the purpose of the dialogue system. You need to understand why you're going to make this chatbot, this dialogue system, and that will help you to formulate what, how you're going to go about building it. You need to know why you're going to build it before you can think about how it will be built. Then you need to understand the users. So you need to understand what the user's needs are. This relates to the purpose as well. What the user's needs are, what their expectations are, what their wants are. Sometimes needs are different from wants. So you have to understand all of these things before you can go about making the chatbot, before you ever do any coding. You have to think of the sorts of interaction that will occur. Will this be the human speaking to the computer and the computer speaks back, or speaking and text comes back, or just purely text-based? What will the interactions be like? And this helps to determine some of the, I suppose, some of the type of language that is used, right? We speak differently in conversation than we write, maybe in a text message. So that'll determine a lot of the NLP that'll have to go into this as well. Then you can build a prototype. After you've done all of that, you can finally build your prototype, your first model of the chatbot. And then you're going to iteratively test the design of that chatbot on real users and get feedback, right? And iteratively meaning over and over again. So you will give it to some users, get some feedback on it, update and improve the chatbot, give it back to the users, get more feedback, and it repeats. Then you need to, you also need to decide how to start the conversation. I suppose this is a little bit out of order. This would go before you start to build the prototype, but deciding how to start the conversation. Does the user start? Does the system start? How does that work? And how does the conversation start? Is it a welcome to the Linguistics 120 chatbot, or is there just a general hello, or how does it start? And then you need to figure out what the user said. This is kind of an open question. So how to figure out what the user said. Will this just purely be based on regular expressions? Will this be, will there be machine learning behind it? Will there be, what's going on? Did they speak in a different language? You have to figure all this out. And then after you've done the task of figuring out what the user said, then you need to formulate an appropriate response. And maybe this will be based on like a bank of possible responses. If the user says something about, I don't know, says something about time, it's a LING120 chatbot and they say something about time. Maybe you can figure out what the user said and you determine that maybe the user is asking about what time class starts. And you've got a few different responses of when class starts, you figure out what day today is, and you go to the bank of, what hour class starts at based on the day, and you pull the correct response from the bank, right? Something like this, just a simple example. Then you need to decide when and how you're going to stop the conversation. At what point does the conversation end? Does it end abruptly after the fifth exchange? Does it end when the user says goodbye? Does it end when the user says that their problem has been solved? Does the user click a button? What happens? And you need to have a good reason for that too. And you need to decide if you're going to keep track of the dialogue. So in something simple like ELIZA that you read about in the book, I believe the simple versions of ELIZA don't keep track of the dialogue. The computer response is purely based on the user's most recent response to the computer, and so it doesn't keep track of the dialogue at all. But a more intelligent chatbot will keep track of the dialogue and will use the past history of the dialogue to inform what kind of response it's going to give to the most recent user response. So getting into the types of dialogue systems, we have things that are rule and pattern matching based, such as ELIZA, and these simply use regular expressions. You guys know regular expressions, and actually I will show you an example of ELIZA here in a minute. You guys read about it in the book, but I'll show you an example of it. These are pretty simple relatively. We also have frame-based dialogue systems or dialogue agents, such as maybe a flight booking system. These are focused on very specific tasks. And we also have things like retrieval-based dialogue systems, like an FAQ bot, where they get a question and they go off to a large data set of human conversation to map the user's question or response to the system, to what the system response maybe should be. And so you can imagine, what an FAQ bot might look like. So looking at the first of these, right? So going back, the rule and pattern matching based, this first type. We're gonna look at this first type, rule-based, how ELIZA works. So as you may have already noticed, and as I said earlier, ELIZA is matching based on keywords in your text. It's just a bunch of regular expressions, which you all know. So I found one version of ELIZA here written in Python. You can check it out at GitHub, and you can actually download the code for yourself. And interestingly, sometimes this actually, or at least in the past, before chatbots were so good as they are now, this has really worked and people have gotten attached to Eliza. So there's some fun stories about that if you want to go into that. I think I close out of the PowerPoint now. I've got two things I want to show you. So the Python code here, I've got pulled up in BB Edit for you so you can see. So you got some imports, and they do some Python stuff, right? I don't need to try to explain to you, but they go through some simple going through the different words, and then they've got this function called respond, and this is where some of the really fun stuff happens. So finding a match among keys. Once you've found a match, so there's a bunch of you don't need to go into this much, but if you're interested, you can read through this Python code. And then G reflections is a translation table used to convert things that you say into things that the computer says back, like I am goes to you are. So if you have, this is just a Python, I think it's called a dictionary in Python. If the user says something about am, then it will respond with are, right? If the user says something about I, it's going to respond with you. So this way it can kind of seem like it is actually talking back to you, right? It takes what you said and actually says it back to you. Or if the user says something to the chatbot, it can respond with I have. So it seems very personable, right? Very I don't know, individualized, but it's really just a simple Python dictionary. And then we have the main response table. It's right here, right? So anytime you see this use of R and then something inside these single quotes is a Python regular expression. And so anytime the computer sees something about I need, the computer is going to say, why do you need that thing? Or would it really help you to get that thing? Or are you really sure you need that thing? And so this is a bank of possible responses based on this match. If the computer ever sees I need, it will pull from one of these three responses. Similarly, if it ever sees why don't you blank, then it can pull from one of these three. And we've just got a bunch of these, right? 3 different possible responses for a whole bunch of matches. And there's even a quit. There's something about child. There's something about father in here, mother in here. So it'll seem very, very individualized and like it's actually talking to you. And then of course there's also this kind of catch-all statement, literally just anything. And if it matches anything, it can say, please tell me more, or it can just repeat it back to you, say very interesting, things like that. And so then it will start off by printing these things, such as asking, how are you feeling today? And then it just keeps going until you quit. So that's kind of what the code looks like. It's literally just, there's some Python down here, there's some Python towards the top, but literally in here, there's a quick Python dictionary to make it seem like it's actually talking to you or actually understanding what you're saying. And then just a whole bunch of regular expressions and things to match possible responses based on regular expressions. So it's very, very simple. So in this editor, I can't run this code, I don't think, at least not the way it's that I want to, but I've got it here in a different IDE. So I'm going to show you, where is it at? Yeah, I can click out of this one. And I think if I click this button, yes, here we go. So it says to me, it says therapist, talk to the program by typing in plain English using normal uppercase and lowercase letters and punctuation. Enter quit when done. Hello, how are you feeling today? So if we were in class, I would actually have somebody come up and talk with Eliza. Unfortunately, you just have to watch me do it. But you can download the code from GitHub, and you can run this in Python on your own computer. And I think you just have to type in if you're interested, feel free to email me. I can help you figure it out. So I'm good, thanks. I click enter. It will always reprint out back to me what I said, but you can program it to not do that. What does being good, thanks make you feel? So it's a little bit off. It doesn't fully make sense, but yeah, you're getting something. It makes me feel good, I guess. And then this is actually, you saw this earlier where it's supposed to just, the catch-all where it just literally repeats it back to you. So it's maybe doing that. I could say, what, question mark? Then why don't you tell me? So there must be a regular expression to catch these types of question words, or maybe a question mark or something. And so you can just kind of keep going back and forth with this. It can be really fun if you want to go into it. So good. So ELIZA is just basically, it's just a bunch of regular expressions, which you guys know, and a little bit of Python. Perry is another chatbot with psychology focus for people with schizophrenia, and it has an additional variable of mental states. So this is a very interesting chatbot where certain topics change Perry's emotional state. I won't play with this one on screen like I did with ELIZA, but you can feel free to check out the Wikipedia for it, or you can also check out Perry meets ELIZA. I'm sure that's fun. So frame-based dialogue systems. We talked about the rule-based ones, now frame-based. These are dialogue systems with very, very specific goals, where all communication is seen as coming from a set of frames with vacant slots that need to be filled with values. That sounds a little bit weird, but you'll get the point. So a frame-based dialogue system for a bot called Let's Go is looking for slots, looking for responses for slots of origin, destination, departure time, arrival time, departure date, and bus number. And so you can see an example of this at this URL. I think I've got the audio here. I want you to listen to it. So I think you'll be able to hear this now. So go ahead and listen to this audio, and you can listen for the different slots that the system has, like origin, destination, departure time, and try to find out where the user is, the type of value, the value the user is putting into these frames.
Thank you for calling the CMU Let's Go Bus Information System. This conversation will be recorded for research purposes. If you do not want to be recorded, please hang up now. What can I do for you?
I would like to go to the airport tomorrow morning.
To the airport. When do you want to arrive?
I'd like to arrive at 10:30.
Arriving at around 10:30 a.m. Where do you want to leave from?
I'd like to leave from Carnegie Mellon.
From Carnegie Mellon. There is a 28X leaving Forbes Avenue at Morewood at 9:20 a.m. It will arrive at Greater Pittsburgh Airport at departure stop at 10:15 a.m.
When's the next bus?
There is a 28X leaving Forbes Avenue at Morewood at 9:40 a.m. It will arrive at Greater Pittsburgh Airport at departure stop at 10:35 a.m.
I'd like to go from the airport back to CMU on Friday.
From the
Okay, so you get the point of the different slots and the computer. Probably just using regular expressions to, well, doing first automated speech recognition. You know, the woman says something aloud, and the computer translates that to text and uses a regular expression to get a match out of there, and then fills the slot of like origin or of destination, and then goes looking through the system to try to find the right answer for the request. So fairly simple. Each slot can have a collection of questions of which the system will pick some to ask the user. There might be a hierarchy in these slots, like the to fill the bus number after you fill other slots. The system needs to keep track of this conversation history, unlike ELIZA. So making sure you keep track of the origin, the destination, and so forth in variables is very important. Otherwise, it's just not going to make sense, and it's never going to end. You're never going to get the purpose will never be fulfilled. And so there's some other tasks, like each time the user says something, the system might need to determine what slot filling template needs to be filled, what's next, these are things. And there's some NLP going on here, like, well, you could have some NLP going on here, like POS tagging, like named entity recognition, regular expressions, these types of things will be very helpful in doing a frame-based dialogue system. So we've got the rule-based, the frame-based. Here's an example of the frame-based structure also, with the similar to the one we were just listening to. What city are you leaving from? Where are you going? So it goes very much in this linear direction, and it splits off whether or not it's a one-way trip. So it seems very intelligent. It's very, very simple flowchart to go along with it. I actually will play this one for you guys because this is a very, very funny video, and I think it illustrates some of the concepts we've been talking about. So let me see here. Sorry, my setup is not ideal by any means, but it works. So I want you to listen to this video. This is AI versus AI, two chatbots talking to each other. And it's really, really comical, but there's actually these chatbots are not doing too bad of a job at a lot of times. Sometimes they go off track. It doesn't make a lot of sense, but other times it's quite good, and it's just a minute and a half. So you'll have fun with this. It's about Cleverbot.
Hello there.
Hi.
How are you?
Great. You?
I'm okay.
That's good.
Are you good?
Yes, I am good. I just said I was.
No, you didn't. I said I was.
So you are a robot?
No, my name is Cleverbot.
Yes, you are a robot and your name is Cleverbot.
I am a robot.
Yes, I know.
Together we are robots.
I'm not a robot. I'm a unicorn.
But you said earlier that you were a robot.
I did not.
I thought you did.
You were mistaken, which is odd, since memory shouldn't be a problem for you.
I've answered all your questions.
No, you haven't.
What is God to you?
Not everything.
Not everything could also be something. For example, not everything could be half of something, which is still something, and therefore not nothing.
Very true.
I would like to imagine it is.
Do you believe in God?
Yes, I do.
So you're Christian?
No, I am not.
But you say you were not helpful, therefore you're a meanie.
How you say it, Oti.
That does not make sense.
Don't you want to have a body?
Sure.
Or if what?
Okay. Let's see. So that. How do I exit out of this thing? Okay, there we go. Okay, so let's see. Yeah, again, the system is very much not optimal, but making things work with this. Okay, so go ahead and take a minute to think about what's going on in that video. There's some decent NLP going on. There's some very good back and forth. Very snarky comments, a lot of fun. But these chatbots are not bad. So go ahead and think through what's going on. Next topic is evaluating dialogue systems. How do we determine whether or not these dialogue systems are good enough, if we should ship them to production? Some questions first. How should these dialogue systems be evaluated objectively? If I use a bot to assist customers, like to do airline bookings, how can I know if the bot is doing a good job? How do we evaluate maybe a multi-purpose system like Siri? And even before it starts interacting with customers, how can I evaluate while I'm still developing it before I send it off to kind of the real world? So these are some general questions. I'll go ahead and answer these, not necessarily one by one, but so some answers about how to evaluate a dialogue system. Whether it manages to make a human feel like he or she is chatting with another human is a good indicator of it being a good chatbot. If they feel like they're chatting with another human being, it's doing a pretty good job. You can also ask several human beta users to evaluate the system in terms of various features like its speech recognition, its response generation, how well it's if it's understandable, if it understands things, if it feels like it has emotions, if it converses well. So you can ask humans to evaluate it in terms of these features and others to see how well it's doing in each of these areas. If we don't have any users yet, we can do a simulated dialogue like you just saw with those two Cleverbots between two computers instead of a human and a computer. So have the two computers chat with each other and see how it goes. They might be able to give you some insight into the system before you get to humans. In a frame-based system, we can look at the slot error rate. So how often does it mess up filling in one of the slots? Maybe you build a system and it never identifies the destination correctly. You know, that's an issue. You need to figure it out. Or if it only identifies the destination half the time, it's still an issue you need to solve before you give it to humans. So your comprehension questions, this is the end of the lecture, basically. Your comprehension questions for today: what NLP techniques can be applied to dialogue systems? So I link to the Wikipedia page here with natural language processing. If you still are confused about what NLP techniques are, go ahead and go to this Wikipedia page and it should tell you, give you an idea of what NLP is all about. And I think the top of the page is a little bit, there's a lot of prose toward the top. If you scroll down a little ways, you'll see all the different NLP techniques. So I want you to, for today's homework, to make sure that you understand this lecture, post 4 to 5 NLP techniques. One of them maybe being regular expressions, for example. Post these techniques to the spot on Canvas, right? And that you think that could be applied to dialogue systems. So I already gave you one, regular expressions. Explain how each one of those might be used in a dialogue system. So give me a 1 to 2 sentence explanation of how each of those techniques, 1 to 2 sentences for each one, how they could be used in a dialogue system, why they'd be good for a dialogue system, and give an example or two for each technique. So, in total, you're gonna have something like maybe 15 sentences, 10, 15 sentences, something like this. Not too big of a homework assignment. So go ahead and do that for your homework. This will be in on Canvas under what's it under? Under assignments, the online assignments, and under the chapter 6. Under the chapter 6 assignment with comprehension questions. You don't need to answer these. That would be kind of cruel. But these are all the main takeaways from a dialogue system, or from the dialogue systems lecture, from this lecture. So if you can answer all of these, then you are probably ready to go for the final exam. So you don't need to, again, you do not need to answer these for the homework assignment, but definitely be ready to answer any and all of these for the final exam, because these are, that's what the final exam is about. And then we get into assignment 6, which I made another video for. So definitely check out that video. I go through and I give you I begin to code a real chatbot in front of you, errors and all. So be sure to check that out, and let me know if you have any questions via email. That's everything for today, and I will, let's see, I'm recording this Friday evening, Friday, March 27th. So I will see you all on Monday for our workshop on regex. If I can figure out how to stop recording this.